All right, hello math fans. All right, so what we're going to do today is talk a little bit more about positives and negatives, where the different trig functions, the signs in different quadrants. Okay, so let's kind of review just a little bit. We've talked about this already, but if you're given the sine of theta is equal to 1/2, and I ask you for cosecant of theta, you're going to tell me that's just the reciprocal, right? 2/1. Of course, you reduce it whenever you can, so it's equal to 2. That's pretty easy. Okay, so here, let's try another example. Tangent of theta is equal to root 5/7. So cotangent of theta is going to be 7/5, right? Just reciprocal. Now make sure you rationalize it, and you get 7√5/5. Sweet. Okay, so here's another one. You get cosecant of theta is equal to 2.105. Now notice both of these answers, math fans, are exact answers. Okay, this is not an exact answer. I mean, I guess you can look at it and say, well, gee, yeah, it is. It's really 2 and 105 thousandths. What I want you to do is understand, usually if it's in a decimal, it's not going to be exact. So you're going to put this in your calculator. All right, and so you're going to use your calculator, and you're going to say the sine of theta, because that goes with cosecant, is equal to 1/2.105. All right, so you use that, put that in your calculator, and you get that equal to 0.475. Okay, that's not bad. All right, so let's try another one here. What about if I give you, let's say the sine of theta is equal to, let's do 1/2. We already did that one already. But I'm going to do, instead of cosecant, I'm going to do what's the tangent of theta. Okay? So what you're going to do is, obviously, with this, you have your ratio is y/r, so y is 1, r equals 2. So we have to figure out the value of x, right, to get tangent, because tangent is y/x, the yax. And so we're going to do x squared using Pythagorean theorem, right? So x squared equals r squared minus y squared, right? Just kind of move things around a little bit. X squared plus y squared equals r squared. So you get x squared equals 2 squared minus 1 squared. So x squared equals 4 minus 1 is 3. X equals root 3. Okay, so you guys agree that tangent of theta then is y/x, so it's 1/√3, which is equal to, rationalize it, root 3/3. Oops, root 3/3. Okay, are you good with that? Well, that's not 100% true. Okay, and this is the reason why. Let me sketch this real quickly here. Okay, I'm going to sketch this initial guy, sine of theta equals 1/2. Now, do you guys agree it's y/r, and then x is, just sketching that, I'm over here someplace, right? So isn't this a 1, and isn't this 2? So this is going to be my answer, right? This is going to be my root 3. Well, does it have to be just sketched there? Can it be sketched here? Right? Here is, oops, here's your 2, and here's your 1. That's the same. This information, can't that be used here and here? Either one? So this is the deal. It's root 3 here, but what's it over here? It's negative root 3. So how do you know which one's which, right? Because truly then, the tangent would be changed. Instead of y/x being root 3/3, it'd be negative root 3/3. So the deal is that I have to give you a little more information. I actually, unless it's just a reciprocal, because reciprocal is easy, right? A reciprocal of a positive is a positive, reciprocal of a negative is a negative. But if I have to actually figure out a different trig function, I have to not only provide you with that initial ratio, but I also have to provide you with the quadrant. So like if I gave you this exact same problem, and I asked you for the tangent of theta, I would have to say quadrant 2. And then you go, oh, okay, we're in this quadrant here, so x is negative, so the answer would be negative root 3/3. Okay, so it's just something important to keep in mind here. All right, I want to talk about the signs in different quadrants. Okay, so let's talk about sine of theta. And sine of theta, we're gonna, if you guys remember, just the quadrantals. We did this yesterday. Sine of 0 is 0, and then goes to 1, and then it goes to 0, and then it goes to -1. Okay, and so between 0 and 1 in this quadrant here, do you guys agree if it's going between 0, the range between 0 and 1 in the first quadrant doesn't have to be positive? Because 0, 0.1, 0.2, 0.3, 0.4, right, it's positive. And then what about between 1 and 0? Well, it still has to be positive, right? And then, of course, between 0 and -1, it goes to negative, and -1 to 0, it's negative. So we're going to do this next chapter as far as getting, the sine and cosine, all the trig functions in different quadrants. But now I just want you guys to just understand what the sign is. So the SIGN. Okay, so these are the signs, SIGN for sine, S-I-N-E. Okay, and let's do cosine. Remember, cosine starts at 1, it goes to 0, goes to -1, and it goes back to 0 again. All right, so between 0 and 1, it's positive. Between 0 and -1, it's negative. Between -1 and 0, it is negative. And between 0 and 1, it's positive. Okay, let's do tangent. Well, that one's actually a little more complicated because isn't that 0 and isn't this one undefined here? And 0 and undefined. So how do you do that? Right, that's pretty difficult to to figure out if it's positive or negative. But remember what I taught you guys. Tangent of theta is y over x, but it's also sine of theta over cosine of theta. Very important, all right? Because now I look at my signs for cosine and sine. So sine over cosine. So if I'm in quadrant 1, I have a positive and a positive, so that means this one's positive. For the second quadrant, I have a positive over negative, so it's negative. For the third quadrant, I have negative over negative, that's a positive. And the fourth quadrant, I have negative over positive, which is negative. So that's what the tangent is. And now the reciprocal functions are exactly the same, right? This is for sine of theta, but it's also for cosecant of theta. And this one's also for secant. So secant of theta. And then tangent of theta is going to be with cotangent of theta. And those are the same. So that's important to understand that. All right, so that's why I don't need to do another chart. All right, I'm going to summarize all this for you because you're like, oh man, there are so many different pluses and minuses to remember. Okay, here's a nice little summary chart. So I'm going to, I like to keep this up here, so I'm going to kind of do it right on the side over here. In fact, I'll erase this here. All right, so this is the summary chart. This is called the positive chart. And this is where it's positive. So all the trig functions are positive here. Sine is positive here. Tangent is positive here. And cosine is positive here. Okay, of course with the reciprocal functions. So that's the summary chart. Now this is kind of the way you remember it. It's a little weird way to remember it. But ASTC, all students take calculus, which is important. Okay, you guys should be taking calculus. Anyway, that's how you remember it. All students take calculus, and you start with quadrant 1, 2, 3, and you work your way around to 4. If you remember ASTC, you'll be good to go. So let's just kind of do an example here. If I said, what is cosine here? Well, here, we'll just draw it. All students take calculus. Oh, hey, cosine's positive. What is cosecant? Cosecant is positive here. Cosecant goes with sine, so it's positive here, negative, and negative. Okay, it's pretty easy. Okay, so let's do a couple of, I'm going to ask you guys to identify quadrant, or quadrants. Identify quadrants for the given angle. With the following conditions. Okay, so I'm going to say sine of theta. First I'm going to draw my little chart here. All students take calculus. Okay, so sine of theta is greater than 0, and cosine of theta is greater than 0. And I want to look for which quadrant. Okay, so basically what you're doing is you're looking at the chart and you're saying, well, where is sine greater than 0? It's greater than 0 in quadrant 1. And this is an and between here, by the way. It's quadrant 1 and quadrant 2. Where's cosine greater than 0? Quadrant 1 and quadrant 4. So where does it overlap? Because it's and, they overlap in quadrant 1. So the answer to this problem is quadrant 1. Okay, what about sine of theta is greater than 0 and cosine of theta is less than 0? Okay, so again, look at the chart. Quadrant 1 and quadrant 2. Where is it less than 0? It's less than 0 in quadrant 2 and 3. So 2 and 3. So again, it's and between here. And so where do they both have the same quadrant? They're both in quadrant 2. So the answer is quadrant 2. Okay, here's another one. Sine of theta is greater than 0. Secant of theta is greater than 0. And you're like, oh man, secant. Well, remember, it's the same thing as cosine. So sine and cosine. So this is really like the first problem. It's exactly, so the answer is quadrant 1. That's easy. Okay, here's another one. Tangent of theta is greater than 0. Cotangent of theta is greater than 0. Well, aren't they really the same? One's just a reciprocal. So where are they both greater than 0? 1 and 3. And, of course, that's the same thing. So the answer to this one is both 1 and 3. Okay, here's another one. Cosine of theta is greater than 0. Secant of theta is less than 0. Well, isn't secant with cosine? So this one's greater. I mean, just kind of think about it. What's this going to be? It's going to be no solution, right? Because you can't have cosine greater than 0 and less than 0. But if I looked at the chart, it's greater than 0 at 1 and 4. And it's less than 0 at 2 and 3. Okay, that makes sense. So the answer to this one is going to be no solution. Okay, and one last one we'll put on the side here. I might just ask you, where's cotangent of theta less than 0? Just one thing. And of course you're just going to say, oh, well, cotangent is the same as tangent. And tangent is less than 0 in quadrants 2 and 4. Okay, that's pretty easy, right? All right, so let's move on to a couple different problems here. All right, I'm going to ask you guys to give the sign of the 6 trig functions given the angle. All right, so what I'd like you guys to do is make 1, 2, 3, 4, 5, 6, 7, 8 columns in your notes. Okay, so I'm going to have degree. I'm going to have the quadrant that we're talking about. I'm going to ask you where sine is. I'm going to ask you cosine. I'm going to ask tangent. I'm going to ask cosecant. I'm going to ask secant. And I'm going to ask cotangent. Okay, so let's try the first one, 85 degrees. Okay, and let's put a little chart here too. I think that's really handy. All students take calculus. Well, 85 degrees, that is in, let's actually put here, this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270 degrees, just to help you remember that. So 85 degrees is in the first quadrant, and they're all positive. Everything's positive in the first quadrant. Okay, the next one is 105 degrees. Oh, sorry, didn't mean to scare you. Okay, 105 is in the second quadrant. So sine is positive, and cosine and tangent are negative. So then cosecant is positive, and the other two are negative. Okay, let's do 250 degrees. Well, 250 degrees is in the third quadrant, a little bit less than 270. So third. Tangent is the only one that's positive. Right? So tangent and cotangent are positive. Everything else is negative. Okay, 355 degrees. That's a nice highway. That is in the fourth quadrant. And cosine is the only one positive. So positive, and secant goes with that, positive. The rest of them are negative. All right, 600 degrees. That's a hot day. Now, what do? You're like, oh man, 600 degrees, we don't know that one. Well, let's do coterminal. Let's subtract 360, and that's actually 240 degrees. Okay, and 240 degrees is now in the third quadrant. And that means tangent's the only one that's positive. So tangent and cotangent, and the rest of them are negative. And here's another one here. So these are together. Negative 185 degrees. Again, do coterminal, add 360, that gives you 175 degrees. Much easier. That's barely in the second quadrant. So sine's the only one that's positive there. Sine and cosecant, and the rest of them are negative. Okay, that's really not too bad. Just you're gonna have to know this. This is really important for the next chapter. Knowing the signs, very, very important. Okay. The next thing is, next example is find all trig functions when cosine of theta is equal to 3/5 and theta is in quadrant 4. Remember, that was that problem I did a while ago. You have to know it's in quadrant 4, otherwise, like cosine is x over r, but I wouldn't know what value is y. I mean, is y positive or is it negative? That gives us the clue. So what I want you guys to do is make a quick sketch. We're in quadrant 4. Let's label stuff. Well, we know it's x over r, so let's put our r here as 5, and our x is 3. Okay, so remember with Pythagorean theorem, isn't this 4? But its y value is negative. That's important. So you might want to write that down just to kind of help you. X is 3, y is negative 4, and r is 5. Super important, because now we're going to do all of our trig functions. Okay, and we know sine of theta is y over r, so it's negative 4/5. Cosine of theta, that's given. That's 3/5. That's easy. And tangent of theta is the yax, so it's y over x, which is negative 4/3. And then these are just reciprocals. So cosecant of theta is negative 5/4. Secant of theta is 5/3. And cotangent of theta is negative 3/4. Wow, that was pretty easy. Sweet. Okay, let's do one more example here. It's the same directions. Find all trig functions when cosecant of theta equals negative 2, and theta is in quadrant 3. All right, so again, it's a great idea to sketch a picture, just to kind of see where we're at. And you're like, well, wait a second, negative 2, what do we do with that? Well, it's negative, so let me write this out here a little bit. Right? Cosecant of theta equals negative 2 over 1. Okay, remember cosecant goes with sine, and sine is y over r, so this is r over y. And then you're looking at this like saying, okay, so r is negative 2. But math fans, you got to remember, r is always positive. That's important. So r can't be negative 2. What is r really? R is equal to positive 2, and the negative really belongs to the bottom. So it's 2 over negative 1, if you want to look at it that way. So your y value is -1. Very important. Anyway, I'm in quadrant 3, so I'm going to draw it. I'm going to sketch in quadrant 3. So r is 2, y is -1. Well, of course, now this with knowing it's quadrant 3, it basically tells us that x is negative. Okay, so we're going to use our Pythagorean theorem here, and x squared plus y squared equals r squared. So x squared equals r squared minus y squared. Excuse me. So x equals the square root of 2 squared minus a -1 squared. So x is square root of 4 minus 1, right? That becomes positive. So 4 minus 1 is 3. So x equals the square root of 3. So that is this guy right here. And of course it is negative. Okay, that's all the information we have, or we need, -√3. So this is it, man. And we got all the rest of our stuff here. So let's do sine of theta is y over r. So it's -1/2, which that was an easy one. Cosine of theta is equal to x over r, so -√3 over 2. And tangent of theta is equal to the yax. So it's -1 over -√3, which is positive 1 over √3, but we have to rationalize it. So you get √3, positive √3 over 3. Okay, and remember, of course we're in quadrant 3, so tangent's positive there. That makes sense. Okay, and then we have cosecant theta. That's given, so that's easy. That's -2. And Dan, don't reduce it, right? Don't tell me it's -2 over 1, please. And then secant of theta is equal to that's cosine, right? So that that's just the reciprocal of cosine, so it's going to be -2 over √3. Okay, r over x. Then rationalize it. So we get -2 √3 over 3. And then cotangent of theta is the evil distant cousin, the psi. And that's, as opposed to flipping the tangent, the one we found, look at the original problem. Isn't it -1 over -√3 or 1 over √3? So if I flip it, I just get √3. Okay? So that's it, math fans. That is, dealing with sines. Very important. Okay, that's just a huge thing. And I'll tell you that all students take calculus is super helpful. All right? That's it, math fans. Have a great day. Goodbye.